All right, guys. So in today's video, we're going to talk about how you can use those trig ratios that we talked about in section 3.1, namely the sine, cosine, and tangent, in order to solve for a missing side of a triangle. Here's the steps to doing that. Step number one, we're going to make sure we label the angle that we are using. Step number two, we're then going to label the sides, which are given to us according to the angle, so whether they are the hypotenuse, opposite, or adjacent sides. Step number three, we're going to pick either sine, cosine, or tangent, depending on what is appropriate. And then step four, we're going to solve whatever equation is left. So let's take a look at the first one. So for sine, if you are looking for the sine of the acute angle, remember you're taking the length of the opposite side divided by the length of the hypotenuse. Remember that this is the so part of SOHCAHTOA. So let's take a look at a couple examples. So we're going to start by looking at our angle right here. Based on that angle, x would be our opposite side, 30 would be our hypotenuse. So we would say that the sine of that angle, sine of 28 degrees, is equal to our opposite x divided by our hypotenuse, 30. And then just like we did in section 3.1, we're then going to solve for x. And so in this case, that means multiplying by 30 on each side. So that'll leave us with 30 sine of 28 degrees is equal to x. And then remember, this is where you'll go ahead, put that into your calculator. So 30 sine of 28 is equal to 14.1 to the nearest tenth. All right, let's take a look at another one. So similar idea, we've got 30 degrees as our angle, 13 as our opposite, x is our hypotenuse. Setting this one up, sine of 30 is equal to opposite over hypotenuse, so 13 over x. Remember, this is a special time with variable in the denominator where you can swap that with the other side of your equation to get that x is equal to 13 divided by sine of 30. And then all that's left is to put that in your calculator to get a decimal approximation. And it turns out that that's going to be equal to 26. In fact, since it's exactly equal to 26, we don't even need the approximation sign. We can actually use an equal sign. All right. So let's take a look at cosine next. So cosine is going to be the length of the adjacent side divided by the length of the hypotenuse. Remember that this is the part of SOHCAHTOA. So let's take a look at a couple examples. On the first example, we've got our angle 38, and we've got our adjacent side x, and our hypotenuse, which is 40. So we would say this time that the cosine of 38 degrees is equal to our adjacent side divided by its hypotenuse. And then remember, when you've got a number in your denominator, you multiply by that number on each side. So that'll leave us with 40 cosine of 38 is equal to x. And then we just have to put that into our calculator. So 40 cosine of 38 is going to be 31.5. Okay, let's take a look at another example. So we've got our angle 64, we've got our adjacent side, which is 25, and our hypotenuse, which is x. So the cosine of 64 equals 25 over x. Now, once again, whenever you've got that variable in your denominator, just swap that with the other side of your equation. So x would be equal to 25 divided by cosine of 64. All right, so let's figure out what that would be. 25 cosine 64, about 57.0. All right, finally, let's talk about tangent. So when you're looking for tangent of the angle, that's the length of the opposite side divided by the length of the adjacent side. Remember that this is the TOA part of SOHCAHTOA. All right, so let's take a look at a couple examples of this as well. So we've got our angle, which is 66 degrees. We've got our opposite side, which is x, and our adjacent side, which is 18. So we'd say that the tangent of 66 degrees is equal to our opposite over adjacent, so x over 18. Remember, when you've got a number in your denominator, you multiply by that number instead of switching. So you'd have 18 tangent of 66 degrees is equal to x. Then we just need to find a decimal approximation. So 18 tangent of 66 is about 40.4. Now this time it did have some labels, so let me go ahead and include that. So about 40.4 centimeters. All right, one last example, and then we'll kind of take a look at some mixed examples. So we've got our angle, which is 62. We've got our side opposite that angle, which is 24, and the side adjacent that angle, which is x. So we'll take tangent of 62 is equal to opposite over adjacent. This time we do have a variable in our denominator, so go ahead and swap that with the other side of the equation. So x is equal to 24 over the tangent of 62. And then let's go ahead and type that in. So 24 divided by tangent of 62 is about 12.8. And again, this also had labels, so I'm going to put centimeters after it. Okay, now those should be pretty easy because they were telling you which of the ratios to use, be it sine, cosine, or tangent. They won't always just tell you this is what you need to use. It's going to be up to you to figure out what would be the correct trig ratio to use. So let's talk about how to do that. We've got 4 more examples to practice doing just that. So in our first triangle, let's first just make sure we know which angle we are using. So we're using 28 as our angle. Based on that 28-degree angle, we've got x, which is the opposite side. We've also got 19, which is our hypotenuse. And again, that's not the adjacent side. The adjacent side would be over here, but that's opposite the right angle. So that would have to be the hypotenuse. So now, deciding which of the trig ratios to use. So I'm just going to write this at the top of this screen. So this is where we're going to use SOHCAHTOA to help us out. So we're looking for where would we see opposite and hypotenuse together. So O and H, that's right here. So we're going to use what's in front of those, which is the S for sine. So we're going to take the sine of 28 degrees is equal to opposite over hypotenuse, so x over 19. And then multiply each side by 19. So 19 sine of 28 is equal to x. And then we just need to approximate that. 19 sine of 28 is about 8.9 to the nearest tenth. And no labels this time, so we should be good to leave it like that. Okay, let's take a look at another example. So we've got 41 degrees. So based on that, we've got our opposite side and our adjacent side, because remember, only the side opposite the right angle would be your hypotenuse. And we don't have that this time. So now, opposite and adjacent, O and A, actually is right here for SOHCAHTOA. That tells us we're going to use tangent to set up this problem. So tangent of 41 degrees equals opposite over adjacent, and now we just solve for x. So multiply each side by 32. So 32 tangent of 41 is equal to x. We'll see what that is approximately. So about 28.7. All right, 2 more examples here. On this next example, we've got our angle, which is 43. We've got our side that's attached to it, the adjacent side. We also have the side opposite the right angle, so that would have to be our hypotenuse. So we've got A and H based on SOHCAHTOA. AH tells us to use cosine. So we're going to use cosine to set up this equation. So cosine of 43 is equal to adjacent over your hypotenuse of 36 over x. And then remember, to get x by itself, just swap it with the other side of your equation. So x is equal to 36 over the cosine of 43. All right, so let's type that in. 36 over cosine 43, 49.2. All right, one last example here. Let's take a look at it. So we've got our angle, which is 72. We've got the side opposite that angle, which is 25, and the side that's adjacent, which is x. The side opposite the right angle was not given to us, but that would have been the hypotenuse. Okay, so opposite and adjacent, we've already done one of these before. We know that that's going to be tangent. So tangent of 72 equals opposite over adjacent. And then once again, with x in your denominator, swap sides. So x equals 25 over the tangent of 72. And then we'll go ahead and type that in. 25, tangent of 72, and we get 8.1. All right, guys, that is it for this video. Until next time, have a great rest of your day.